Using a single pole breaker on the high leg of a delta service presents several potential problems. Firstly, overloading on the high leg can occur. When using a single pole breaker on the high leg of a delta service, all the current for the connected equipment flows through that leg. This can overload the high leg, potentially causing overheating, wire damage, and increased risk of electrical fires. Secondly, an open neutral condition may arise. If the neutral conductor breaks or becomes disconnected, the voltage across the high leg and neutral will increase to the line voltage, such as 480 volts in a typical 480 volt delta system. This can damage equipment connected to that leg and create a serious safety hazard for personnel. Thirdly, unbalanced load current is a concern. Connecting loads to separate poles of a two-pole breaker ensures that the current flow is evenly distributed between the phases. Using a single pole breaker on the neutral creates an unbalanced load current, which can lead to overheating of the neutral conductor, voltage imbalances, and reduced efficiency of connected equipment. Fourthly, there is a loss of ground fault protection. Two-pole breakers provide protection against ground faults on both phases. Using a single pole breaker on the high leg and neutral does not provide the same level of ground fault protection. Fifthly, code violations may be present. Using a single pole breaker to feed 220 volt equipment from a delta service is typically not permitted by electrical codes. National Electrical Code, NEC, Section 210.4 requires two-pole breakers for multi-wire branch circuits, such as those using a high leg and neutral. It is always best to consult with a licensed electrical contractor for proper installation and maintenance of electrical systems. Considering specific code requirements, NEC 210.4 mandates that multi-wire branch circuits must originate from a two-pole breaker, especially when dealing with a high leg delta system. This is because the high leg, also known as the stinger leg or wild leg, carries a higher voltage than the other phases to neutral, typically around 208 volts in a 240 volt delta system. Using a single pole breaker on this leg can lead to uneven loading, potentially causing the neutral conductor to overheat. NEC 310.15 addresses ampacity and temperature limitations for conductors. Overloading the high leg due to improper breaker usage can cause conductors to exceed their rated temperature, leading to insulation damage and increasing the risk of electrical fires. The neutral conductor in a multi-wire branch circuit carries the unbalanced current from the other phase conductors. If the high leg is heavily loaded while the other phases are not, the neutral conductor can become overloaded. NEC 250.24 C discusses the sizing and installation of the neutral conductor. It is crucial to ensure that the neutral conductor is adequately sized to handle the maximum unbalanced load to prevent overheating and potential failure. Ground fault protection is essential for electrical safety. A ground fault occurs when current flows through an unintended path to ground, such as through a person or equipment enclosure. Two-pole breakers provide ground fault protection by quickly interrupting the circuit if a ground fault is detected on either phase. Using a single pole breaker on the high leg does not provide the same level of protection. NEC 230.95 requires ground fault protection for services of more than 150 volts to ground, but not exceeding 1000 volts phase-to-phase for each service disconnecting means rated 1000 amps or more. This is a critical safety measure to prevent electrical shock and equipment damage. Voltage imbalance can occur when the loads on each phase of a three-phase system are not equal. This can lead to reduced efficiency and potential damage to connected equipment, particularly motors. Using a single pole breaker on the high leg exacerbates this issue by creating an unbalanced load in the system. NEC 408.3 C requires that switchboards and panel boards be arranged to minimize the possibility of phase to neutral voltage imbalance. This is achieved by distributing the loads evenly across the phases. Overheating of electrical components is a common consequence of overloading. When conductors, breakers, or other components are subjected to excessive current, they generate heat. This heat can degrade insulation, weaken connections, and ultimately lead to failure. NEC 110.3 B requires that equipment be installed and used in accordance with its listing and labeling. This includes ensuring that components are not overloaded beyond their rated capacity. Wire damage can result from prolonged exposure to excessive heat. The insulation on conductors can become brittle and crack, exposing the bare wire and increasing the risk of short circuits and electrical fires. Regular inspection and maintenance are essential to identify and address any signs of wire damage. Electrical fires are a serious hazard that can result from overloading, short circuits, and ground faults. Using the wrong type of breaker or improperly installing electrical equipment significantly increases the risk of electrical fires. NEC 700 and NEC 701 address emergency and legally required standby systems. These systems must be designed and installed to minimize the risk of fire and ensure reliable operation during power outages. Equipment damage can occur when electrical equipment is subjected to voltages or currents outside of its rated range. Overloading the high leg can cause voltage fluctuations and current surges that can damage sensitive electronic devices. NEC 647 addresses sensitive electronic equipment and requires that it be protected from voltage surges and other electrical disturbances. Personnel safety is paramount when working with electrical systems. It is essential to follow safe work practices and use appropriate personal protective equipment to prevent electrical shock and burns. NEC 110.26 requires that adequate working space be provided around electrical equipment to allow for safe operation and maintenance. The high leg over delta service has a higher voltage to ground than the other phases. This can create a greater risk of electrical shock if proper precautions are not taken. Always use a voltmeter to verify the voltage before working on any electrical circuit. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing the breaker to trip and to energize the circuit. Using a single pole breaker on the high leg can compromise the effectiveness of the grounding system. NEC 250 provides detailed requirements for grounding electrical systems. Consulting with a licensed electrician is crucial to ensure that electrical systems are installed and maintained in accordance with applicable codes and standards. A qualified electrician has the knowledge, skills, and experience to identify and address potential hazards and ensure the safety and reliability of electrical systems. Regular electrical inspections can help to identify potential problems before they become serious. A qualified electrician can perform a thorough inspection of the electrical system and recommend any necessary repairs or upgrades. Arc flash is a dangerous phenomenon that can occur when a short circuit or ground fault creates an explosive release of energy. Arc flash can cause severe burns, blindness, and even death. NEC 110.16 requires that electrical equipment be marked with arc flash hazard warnings. It is essential to follow safe work practices and use appropriate personal protective equipment to protect against arc flash hazards. Voltage fluctuations can occur when the electrical system is subjected to sudden changes in load. These fluctuations can damage sensitive electronic equipment and cause lights to flicker. Using a single pole breaker on the high leg can exacerbate voltage fluctuations. Power quality is a measure of the stability and reliability of the electrical power supply. Poor power quality can lead to equipment damage, reduced efficiency, and increased operating costs. Using the wrong type of breaker or improperly installing electrical equipment can negatively impact power quality. Harmonics are distortions of the sinusoidal waveform of the electrical power supply. Harmonics can cause overheating of electrical equipment, reduced efficiency, and interference with electronic devices. Using a single pole breaker on the high leg can contribute to harmonic distortion. Transient voltage surges are brief spikes in voltage that can damage sensitive electronic equipment. These surges can be caused by lightning switching events or other electrical disturbances. Surge protection devices can be used to protect equipment from transient voltage surges. The electrical safety is a shared responsibility. Everyone who works with or around electrical equipment should be aware of the potential hazards and follow safe work practices. Regular training and education are essential to ensure that workers have the knowledge and skills to work safely. Proper installation and maintenance of electrical systems are essential for safety and reliability. Neglecting electrical maintenance can lead to equipment failure, increased risk of electrical shock, and potential fire hazards. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician for specific recommendations and solutions. Improper electrical work can have serious consequences. It is essential to hire a qualified electrician to perform any electrical work to ensure that it is done safely and in accordance with applicable codes and standards. Staying informed about electrical safety is crucial for protecting yourself and others from potential hazards. Regular review of electrical codes and standards can help to stay up to date on the latest safety requirements. Remember, electricity is a powerful force that must be treated with respect. Always follow safe work practices and consult with a qualified electrician when in doubt. The High Lake Delta service, while providing the advantage of having both three-phase and single-phase power available, presents challenges in load balancing and safety if not properly understood and installed. The higher voltage to ground in the High Lake requires extra caution and adherence to code requirements. Single pole breakers are generally not designed to handle the unbalanced load conditions that can occur when used in the High Lake, leading to potential overheating and failure. Two pole breakers, on the other hand, are designed to handle balanced loads and provide better protection against overcurrent and ground faults. The National Electrical Code, NEC, is a comprehensive set of standards for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Following the NEC is essential for ensuring the safety and reliability of electrical systems. Electrical codes are designed to protect people and property from electrical hazards. They set minimum standards for the design, installation, and maintenance of electrical systems. Compliance with electrical codes is mandatory in most jurisdictions. Electrical inspections are conducted to verify that electrical installations comply with applicable codes and standards. Inspections are typically performed by qualified electrical inspectors who are trained to identify potential hazards and ensure that electrical systems are safe and reliable. Arc fault circuit interrupters (AFSIs) are designed to protect against fires caused by arcing faults. Arcing faults are a common cause of electrical fires. AFSIs can detect arcing faults and quickly interrupt the circuit, preventing a fire from starting. Ground fault circuit interrupters (GFCIs) are designed to protect against electrical shock. GFCIs can detect ground faults and quickly interrupt the circuit, preventing a person from being shocked. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Surge suppressors are designed to protect electronic equipment from voltage surges. Voltage surges can damage sensitive electronic components. Surge suppressors can absorb or divert voltage surges, protecting equipment from damage. Uninterruptible power supplies (UPSs) are designed to provide backup power in the event of a power outage. UPS can keep critical equipment running during a power outage, preventing data loss and downtime. Generators are designed to provide backup power for extended periods of time. Generators can be used to power entire buildings or specific pieces of equipment. Transfer switches are used to safely switch between the utility power and a backup power source. Transfer switches prevent backfeeding, which can damage equipment and endanger utility workers. Electrical safety audits are conducted to identify potential electrical hazards in the workplace. Audits can help to prevent accidents and injuries. Lockout-tagout procedures are used to safely energize electrical equipment before maintenance or repair. Lockout-tagout procedures prevent accidental energization of equipment, which can cause serious injury or death. Electrical safety training is essential for all workers who work with or around electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and emergency procedures. Personal protective equipment (PPE) is used to protect workers from electrical hazards. PPE includes items such as gloves, safety glasses, and insulated tools. The single pole breaker installation on the high leg of a Delta service presents a multitude of safety and code compliance issues, ultimately underscoring the critical importance of engaging qualified electrical professionals for all electrical work. Neglecting these considerations can lead to hazardous conditions and costly repairs.